Have you ever wondered why the sun behaves the way it does? The sun, our nearest star, is more complex and mysterious than you might think. It's not just a static ball of burning gas, but a dynamic and active celestial body that exhibits intriguing phenomena like solar flares, solar winds, and sunspots. Each of these phenomena is a spectacle in its own right, but they are not just for show. They have profound effects on our planet, from influencing our climate to disrupting our technology. Solar flares, for instance, release bursts of energy equivalent to millions of atomic bombs, while solar winds constantly stream plasma into space, sometimes reaching Earth. And then there are sunspots, dark patches on the sun's surface that hint at intense magnetic activity. These strange behaviors of the sun are not random. They're governed by a set of fundamental principles. To understand these oddities, we need to delve into the fascinating world of heliophysics. So, what exactly is heliophysics? Well, in the simplest terms, heliophysics is the science that studies the sun and its effects on the solar system. Let's break down the term. Helio is derived from Helios, the Greek god of the sun, signifying the central object of this study. And physics is, as you might already know, the study of matter and its motion, along with related concepts such as energy and force. So when we say heliophysics, we're talking about the physics of the sun. But heliophysics isn't just about studying the sun's surface, its glowing facade that we see from Earth. It goes way beyond that. It delves into the sun's atmosphere, the corona, and the solar wind, a stream of charged particles that the sun constantly emits. These particles travel across the solar system, influencing it in ways more than one. Heliophysics also studies the space influenced by the sun's magnetic field, often referred to as the heliosphere. This vast region of space extends well beyond the furthest planet in our solar system. It acts as a cosmic weather vane, directing the flow of high-energy cosmic particles. Understanding the sun's magnetic field is crucial as it drives solar activity, including solar flares and coronal mass ejections. These phenomena can have significant effects on Earth's magnetic field, leading to what we call space weather. This space weather can affect our satellites, power grids, and even our climate. So heliophysics isn't merely a study of the celestial body that lights up our day. It's a deep, comprehensive exploration of how the sun's processes affect our solar system and, more importantly, our home planet. It's about unraveling the mysteries of the sun, from its core to the edge of its influence. Now that you know what heliophysics is, let's explore how it helps us understand the sun. Did you know that the sun's behavior is largely dictated by its atmosphere and magnetic field? Let's delve into this fascinating topic. The sun's atmosphere is composed of three main layers: the photosphere, the chromosphere, and the corona. The photosphere, the sun's visible surface, is where sunlight and heat are generated. Moving outward, the chromosphere, or sphere of color, hosts solar flares, which are sudden flashes of increased brightness. The outermost layer, the corona, though less bright, is incredibly hot, reaching temperatures of millions of degrees. Now, what role does the sun's magnetic field play in all of this? Well, it's quite significant. The sun's magnetic field lines are like highways for solar material and energy. They guide the charged particles that make up solar wind and coronal mass ejections, both of which can cause space weather events that impact our planet. But here's where things get truly captivating. The sun's magnetic field isn't static. It undergoes a cycle known as the solar cycle, which lasts approximately 11 years. During this cycle, the magnetic field flips. The northern and southern magnetic poles switch places. This flip-flop is associated with a change in solar activity, notably the frequency and intensity of solar flares and the production of solar wind. At the peak of the solar cycle, the sun's magnetic field is at its most complex, and solar activity is at its highest. This period is known as solar maximum. Conversely, during solar minimum, the sun's magnetic field is well ordered and solar activity is at its lowest. Essentially, the structure of the sun's atmosphere and the behavior of its magnetic field are intrinsically interwoven. Together, they shape the sun's activity, influencing everything from solar flares to solar winds. As you can see, heliophysics provides a deep insight into the sun's atmosphere and magnetic field. We're just beginning to scratch the surface of this radiant celestial body and its profound influence on our solar system. You might be wondering, how does heliophysics affect us here on Earth? Let's dive right in. Heliophysics plays a crucial role in understanding space weather, a term that encompasses the conditions and phenomena occurring in space that can affect Earth and its technological systems. It's not just about the weather we experience on Earth, but it's about the weather that's happening in the vast expanse of space around us. One of the most dramatic examples of space weather are solar flares, which are sudden, intense bursts of radiation from the sun's surface. Now, these solar flares can be quite disruptive, especially when they're directed towards Earth. They can interfere with communication systems, including radio and GPS signals, and even affect power grids. Imagine being unable to use your GPS while driving or experiencing a citywide blackout. That's the kind of impact solar flares can have. But thanks to heliophysics, we're not left in the dark. Heliophysics provides us with the tools and knowledge to monitor the sun's activity, predict solar flares, and prepare for their potential impact. It's like having a weather forecast but for space. It allows us to take protective measures, such as adjusting satellite orbits or shielding sensitive electronics to minimize the impact of these solar events. But solar flares aren't the only space weather phenomena that heliophysics helps us understand. There's also solar wind, a stream of charged particles constantly flowing from the sun. When this solar wind interacts with Earth's magnetic field, it can create beautiful auroras, but can also disrupt satellite operations and communications. So, while the sun might seem distant and unchanging, it's actually very dynamic and can have a significant impact on our everyday lives. But with the help of heliophysics, we're able to understand, predict, and protect ourselves from these solar events. In essence, heliophysics is our shield, predicting and protecting us from the sun's unpredictable behavior. So, what does the future hold for heliophysics? The future of heliophysics is as bright as the sun itself. With the advent of advanced technology, scientists are moving towards an era of unprecedented understanding of our star and its influence on the solar system. Heliophysics, as a discipline, is on the cusp of a golden age of discovery, and the implications are far-reaching. Ongoing research is focused on the sun's magnetic field and its impact on space weather. The more we understand about these phenomena, the more we can predict and mitigate their effects on our technology and infrastructure. This knowledge is crucial, not just for life on Earth, but also for future space exploration missions. The potential for new discoveries is immense. With every solar cycle, we gain a deeper understanding of the sun's behavior and its relationship with the Earth. We are beginning to comprehend the complex interplay of the sun's magnetic field, the solar wind, and cosmic radiation. Future missions will continue to probe the sun's mysteries. The Parker Solar Probe, launched in 2018, is already providing groundbreaking insights into the sun's corona and solar wind. And there are more exciting missions on the horizon. The European Space Agency's Solar Orbiter, for example, will provide unprecedented close-up views of the sun's polar regions, a largely unexplored territory. The importance of continued study in this field is paramount. As we venture further into space, a solid understanding of the sun and its behavior is essential. Heliophysics can help us predict and prepare for solar storms, protect our astronauts, and safeguard our satellites. It holds the key to making long-duration space travel a reality. Yet, the true value of heliophysics extends beyond practical applications. It offers us a unique perspective on our place in the universe. The sun, after all, is just one of countless stars in the cosmos. By studying it, we gain insights into the nature of stars and the fundamental processes that drive them. As we continue to unravel the sun's secrets through heliophysics, we get one step closer to fully understanding our place in the cosmos.